If you've ever spent time watching a flock of white-throated sparrows scratching the leaf litter, you may have noticed something curious. Not all of them look alike. Some have bright white head stripes, while others are more of a soft tan. These aren't just variations in plumage. They represent one of the most intriguing examples of natural genetic diversity in North American songbirds. Let's explore what makes the white-striped and tan-striped morphs so different and how these differences go beyond just their color. At first glance, both morphs share the white-throated sparrow's classic field marks: a crisp white throat patch bordered by dark malar stripes, and a yellow spot in front of each eye. But if we look closer, we'll also see that white morph birds have the bright white and black crown stripes, while the tan morph birds have the muted tan and brown crown stripes, giving them a softer appearance. These differences are visible in both males and females, and remarkably, they're linked to behavior, genetics, and even mating strategies. Here's where things get very interesting. The white and tan morphs are controlled by a chromosomal rearrangement, a large chunk of their DNA that flipped and reinserted itself on chromosome 2. This rearranged version of the chromosome is known as 2N, while the standard version is just 2. White striped birds carry one copy of each, 2 and 2N. Tan striped birds carry two standard copies, 2 and 2. Scientists call this large rearranged section a supergene because it controls a whole suite of traits, from color to behavior. Interestingly, two copies of the rearranged chromosome, for example 2N and 2N, are never found. These individuals don't survive embryonic development. This means every successful white-throated sparrow population is a mix of both morphs, genetically and behaviorally balanced. Unlike most bird species, where pairings are largely random or based on territory timing or selection for a mate for traits, white-striped birds almost always mate with a tan-striped bird and vice versa. This pattern is called negative assortative mating, a mouthful that simply means opposites attract. By pairing this way, the population stays genetically balanced, with both morphs passing on their unique traits to the next generation. So, why this system? It mostly has to do with behavior. The chromosomal differences affects not just their looks, but hormones and behaviors as well, leading to distinctive personality types on what morph they are. For example, white morphs tend to be more aggressive and territorial, sing more, spend less time feeding young, more time defending their territory, and tend to have higher testosterone. While tan morphs tend to be less aggressive and more cooperative, sing less, and provide more parental care, and have lower testosterone. In short, overall, white morphs are the bolder, louder, risk-taking types, while tan morphs are calmer and more cooperative, and when paired together, they balance each other out, ensuring both strong territory defense as well as providing good parental care. This genetic supergene system is an evolutionary marvel. This unique system has fascinated scientists for decades because it is so rare in birds. The white-throated sparrow's two-morph strategy is a living example of how genetic diversity can shape behavior and help a species thrive. By maintaining both morphs in the population, the species benefits from diversity in their strategy. Aggressive birds help secure resources and defend territory, and the more passive birds are good at providing parental care and raising their young. So, next time you're out looking at your feeder or out bird watching and encounter a white-throated sparrow, look closely. Is it a bright white-striped bird? And how is it behaving? Is it chasing rivals or acting more bold? Or the tan strip you see, how is it behaving? Is it more quietly foraging or is it tending to a nest? You're not just seeing color variation in these birds, you're seeing one of the most fascinating examples of behavioral genetics in the bird world. Thanks for listening, all you lovely bird nerds, and if you enjoyed this episode, please feel free to like and subscribe to the channel. And if you want to continue learning about birds and be a better birder in a guided program, please consider signing up for my Birding Academy by joining the waitlist for its expected mid-December 2025 launch. Link will be in the description. And until next time, happy birding.